reaction is desorption. This is a desorption. This is a desorption. So this is a sorption process, include adsorption and desorption. So for the adsorption, we can describe the sorption, use the physical sorption and the chemical sorption. So here we have chemical and the physical sorption. Physical sorption normally used for physical process. For chemical reaction, you must have the chemical adsorption. The chemical adsorption can active the molecular. The molecular can be the reactant. The reactant is active, then the reactant can join the chemical reaction. So the chemical adsorption must occur in the chemical reaction. This reaction is a catalytic chemical reaction. So adsorption means the molecular, the reactant, adsorbed on the surface. This surface is catalyst. This is the chemical adsorption. So let's look at the chemical adsorption. This is the catalyst surface. On the catalyst surface, there are many active sites. For example, this is the active site. Then the molecular of reagent or product. The molecular adsorbed on the active site. Then the adsorbed, let's look, the adsorbed product is the AD. Here the reactant is A. So A adsorbed on the active site to make the A sigma. Here the A sigma is the adsorbed. Adsorbed A means the A has been activated, is active. So the A can react with another reactant to produce the product. So this is the chemical adsorption, and for the catalytic chemical reaction. So let's look. This is the adsorption. Okay. Can you understand adsorption? Okay.
Yes, sir.
Okay. Did you understand the chemical adsorption?
Yes, I
I
did.
mean, do you think I answer your questions?
Yes, but I also want to know the reaction rate also, how it also involves with the reaction rate.
Okay. How about the reaction rate? Please tell me the details about your question about the reaction rate.
How do I describe adsorption using the reaction rate?
Yeah, let's look for this reaction. This is the forward reaction is the adsorption. So you can write the reaction rate. I write here A plus the sigma. The forward reaction, we use the rate constant K. Then to produce the A sigma. Then this step, let's look this step, is elementary reaction. Elementary reaction. So you can use the mass action law. Mass action law. I just repeat this knowledge. Mass action law, the mass action law tell you to write the reaction rate for this elementary reaction. Ra equals K. Here is the rate constant, the K. Multiply the concentration for each and every species. For A, here you can use the Ca or Pa. Express the concentration. But for Let's look at for the sigma. Sigma is active site. How to express the active site concentration? Here we use the coverage. I told you use the coverage. Coverage we use the theta. Here theta is the coverage. Here is the void. What's the void? Means this active site is not occupied by the reactant or product. Let's look. This is the void. So here we use the void. Subscribed only use the V, means the void. So this is the reaction rate. Do you understand?
Yes, I
Hello?
do, sir. Yes, I do. Yes, I do.
Okay. If you understand, let's continue my course. Okay. Now let's look. Biomolecular and single site adsorption. I just told you this is a non-elementary reaction, so this reaction can be separated to two steps. One is A adsorbed on the active site to make the active A. Another step is B, reactant B adsorbed on sigma active site to produce the B sigma. So let's look. The active site. Here is the active site. Surface of the catalyst. This is the surface of catalyst. Here we have one active site. Not single site means the one kind of active site. Now this is the active site. The active site can be absorbed by A, can be absorbed by B. So this is the competitive adsorption. A and B, both of A and B can absorb on the active side. So let's look. Here you will have the theta V is the void. What's the void? Means active side is void without any species adsorbed on this side. So we use the theta V. This theta V means the coverage of void active side. Plus, here is the theta A adsorbed active side, plus theta B adsorbed active side, equals 1. Total coverage equals 1. So you have theta V equals 1 minus theta A minus theta B. So for this reaction, for this chemical reaction, let's look. You can get the reaction rate. Let's look. Ra equals Ka Pa. Ka Pa just for this reaction. For this reaction rate for A equals, use mass action law, use Ra equals here Ka for the A species adsorption. So we use the subscript AA. Multiply Pa. Here we use the P, not use the C. No, doesn't matter, you can use the Ca. The Pa multiplied concentration of theta. I just told you for the theta active site, we use the coverage to calculate the concentration. So here you can get the Raa equals Ka Pa for gas phase reactant. This is for the active site. Active site, you can image active site is solid reactant. So for solid reactant, we use the coverage. So this one is the theta V. We get the theta V. So let's look at the RDA. Also use the mass action law. For elementary reaction, let's look the backward reaction. This is the only reactant, so the concentration only include the theta A. The rate constant is KdA, so the RDA for A species desorption, the rate equals KdA multiply theta A. Now let's look second step. This is the first step. This is the second